This will be the first in a series on our place in the universe. And to begin, we'll look at our Earth. And here are some important ideas we'll encounter. Now, the Earth, of course, is a planet, and NASA defines a planet as a celestial body in orbit around a star, is nearly round, and has cleared its orbit of other debris. So there are three parts to the definition. Let's take one of the parts, orbiting. Here's a picture of our solar system. We have the sun, we have the planets orbiting our sun. Now, the planets orbit our sun because of gravity, and we know that gravity is a force of attraction between objects with mass. And the gravity between the sun and the planet keeps the planet in its orbit. Planets don't crash into the sun because they're already in motion. Now, should gravity suddenly stop, the planets would move off in a straight line at a constant speed. On the right, we see a diagram of the forces involved. We have the sun exerting a gravitational pull on the planet. Now, the planet also pulls on the sun, but we're focusing on the sun's pull. That's the force that's going to keep the planet in motion. Again, the planet already has momentum. It has motion, and if no other forces were acting, it would be moving in a straight line at a constant speed. But the sun's pull of gravity bends that path into a nearly circular orbit. Now, gravity is also responsible for keeping us anchored to the surface of the planet. And so now let's briefly take a look at the difference between weight and mass. Weight is a measure of the gravitational force on an object. Weight depends on the location of the object relative to other objects that exert a gravitational pull. Mass is a measure of the amount of matter in an object. Mass does not change with a change in location. And we can see the difference with this diagram over here. Here we have the Earth and a person on the Earth. Now, they have a certain mass. There's a certain amount of material that their body is made up with. And we'll define that as 50 kilograms. So this person has a mass of 50 kilograms. Their weight on Earth is 110 pounds. That is a measure of the gravitational pull of the Earth. Now, the person is also pulling on the Earth, but we're thinking about it from the point of view of the Earth pulling on the person. And that's their weight. Now, if that person goes over to Mars, the amount of matter in their body does not change, so their mass does not change, but their weight is reduced. And that's because Mars has less mass than the Earth, and so Mars exerts a smaller gravitational pull on the person, and so they weigh less. Now, let's consider the other component of the definition of a planet, that the body has to clear its orbit. If we look down here at the right, we see the orbits of the planets are cleared in the sense that there's not a lot of rocks and debris and asteroids and stuff in the orbit. So that's what NASA means by cleared orbit. But scientists think in the early days of the solar system, when the Earth was forming, it looked more like the top picture up here. So we have our new sun here, and surrounding the sun was a disk of material, dust and small grains and particles of rock, and that was sort of in orbit around the new star. And it's this material then that is going to coalesce, to aggregate, to form the planets. So in the early stages of solar system formation, the protoplanets were situated in a disk of material, space dust and small rocks. And as planets became larger, their increased gravity made them even more efficient in clearing their orbits of the remaining material. See, here we see a scene where, some rocks are colliding into this little planet here, or it's getting bigger. And as the planets get bigger, they exert a greater gravitational pull on the surrounding material in the disk. So they will be clearing their orbits in time. Now, Earth continues to clear its orbits as meteors are removed when they hit the Earth. Here's a picture taken in Chile of the night sky. There's the Milky Way. But here we see a meteor caught in the act. So this was a 20-second exposure, and a meteor entered the atmosphere. So this is the kind of thing where the Earth's gravitational pull will attract particles in its orbit down to the Earth's surface, but they often burn up in the atmosphere. So the story then of Earth's formation is one where gravity plays an important role. Gravity is going to assemble the material in this disk into larger and larger bodies the size of planets. And as planets get larger and larger, gravity also will have an influence in the shape of the planet. Planets are nearly round because of gravity. Mountain height is limited by the force of gravity that tends to crush the mountain. So in the diagram on the right here, remember all objects with mass exert a gravitational attraction. Well, that means the Earth, in a sense, is itself under the influence of gravity. So all of the parts of the planet are attracting each other. And so we get the force of gravity tending to sort of pull the material towards the center of the object. So if we have a mountain range, this is Mount Everest, growing higher and higher and higher, at a certain point it will crumble under its own weight. So gravity tends to make larger planets spherical in shape. Smaller objects can have non-spherical shapes because there is less gravity pulling towards the center of the object. And these are actual pictures taken by spacecraft of some asteroids in our solar system. And notice they are not spheres. And one final thing about the Earth, we'll note that it takes 1 year for the Earth to orbit once around the Sun and 1 day for the Earth to rotate about its axis. That rotation, of course, is what's responsible for the day-night cycle. We can capture the Earth's rotation with night photography. If we point our camera at the North Star, Polaris, that star is on the axis of the rotation of the Earth. And if we open our shutter for several minutes, we'll capture an image like this. Now, stars normally are points of light, but because of the Earth's rotation, we see the streaks here. And these are called star trails. So we've captured the Earth as it is rotating about the axis centered upon Polaris, the North Star.